My stream summary is ready. I don't need one. I was there. I know what it was like. Alright, now we're streaming. I'm going to go ahead and tell the world. Streaming indie dev with a hashtag. Doing all sorts of torn up ship parts. Paste. And then over here. All right. So, today we're going to go ahead and make this debris that we created last week with this cut system. We're going to go ahead and turn this into something that's a little bit more fun. There are a couple more things I want to do, but I can always do them later. So for now, what we're going to do is we're just going to make these have the proper debris elements. The good news is it's quite simple to make them have the proper debris elements. All you've got to do is drop them into the scene view and start to put stuff on them. So right now there's like stuff here. You can see it's kind of in the middle of Grand Central Station. What we're going to be doing is removing most of this stuff. We just don't need it. But we do need a couple of things. So what we need are the elements from over here, which we can't get through. There we are. This is the basic setup for what we're trying to do. And you can see that there are several different things going on. There's interior blocks. There's two different kinds of interior blocks. There is a kind of grid panel system, and these are ones where if we hit play, we'll see panels. And then there's also these blue markers, and these blue markers are debris broadcast. Alboechi says, I'm here for once. What have I missed this week? I just started, so you didn't really miss much. I have arranged for certain things to break in certain ways, and right now we're just going to make those things look good. Fill them with debris. I don't think we need any of these ships, so we're going to go ahead and just delete all these parts, including you. So I think that most of these are actually, yeah, so these panel injectors and the debris systems are things we're going to want to move into our new system. Now I know I used to have quite a setup. Alboecha says, oh no, he means the last 2 or 3 streams. Well, I took a week off to do a game dev jam. So I released a jam. If you wanted to, you could go and investigate that. So I haven't really done a whole lot in the past week, just because I've been working on other things instead. It looks like I've deleted some of the stuff I was going to use. That's fine. I'm just still getting used to the fact that we've got a lot of random debris here. Trying to sort out, clean stuff up. We don't need the kind of mess that we've been having. We also don't need you. You are all hopelessly obsolete. And there's just a gimbal arm floating in space. It's not actually attached to anything. Where is it? It's an invisible gimbal arm. Alright, well, we'll delete it then. Yeah, I guess I don't need it then. So all we really need to have is the pieces that we're going to need in order to actually create the debris that we're creating. And I'm kind of getting rid of this giant mass of garbage that I've been accruing over the past year. And this is what we're left with, just a flat, broken object. But what we're going to need to do is actually edit this a little bit, because it's not quite nice enough for my needs. So we're going to just put in a little bit of a dent in it. Now we've got 2 different setups for it. It's itself and itself mirrored, as you can see. We actually don't need that at the moment. I'm going to go ahead and delete the mirrored version just for now. And what I want to do is just create a dent that actually goes deeper than this little one I've created here. So for that, we're going to just select this stuff and create a dent. Boom. Not that much. That's a little bit too much deletion. Better. Okay. So you might not have been able to tell the difference, but that was quite a bit of different, not nearly as much deletion going on now. So what I need to do is create a nice little face for our broken areas, which should be like this. I don't think there's anything else selected. Yeah, and then we'll just use Alt F. Nope, Control F. Nope. That wasn't F, that was the problem. And we'll just do a grid fill or something like that, right? Alt F, no, Control F. Fill. It is Alt F. It's just barfing for some reason. That's interesting. It shouldn't have any problem with this. Well, maybe I had something else selected. We'll fill there, and then we will just carve and pull, and then we'll fill here. Alt F. There we are. That's what I wanted to see. And then we'll just keep going down the line here and create ourselves a nice little filled area. First things first, though, we're going to want to delete all of the padded elements because we need to have new padding. No biggie. Just grab them and delete them. And then we'll fill in the same area and give ourselves a new set of elements. So to do that, we can just grab here. But you can see how there's these convex areas. If we do Alt F, we end up with stuff that doesn't quite work, as you can see. So what you want to do when you have convex areas like this is just to grab an area that is a little bit too convex for you and make it so that it's not. And there are a couple of ways to do that, and what we're going to want to do is, I spent so much time trying to figure out this part because I just got started today, and I'm thinking in terms of something else I was doing earlier, and I haven't really got my brain in the mode for this just yet. But what we're going to go ahead and do is fill in these areas, which I think we're going to want to do it like that. I think we're going to need to do it a little bit more. So let's go ahead and just create some elements here. And maybe what I'll do is I'll delete these guys and this guy. There we go. And then what we'll do is we will create that indent like so. Carve it up a little bit, move it in a little bit, and then we'll begin our fills. So here we're going to do the same thing, just fill in the face, carve it up a little bit, move it in a little bit, like this. And then Alt F and Alt F. Okay, so that one didn't quite work. That's fine. We'll just fill it in manually up here because this is the part that's given us trouble. And then we'll Alt F. Better. So you can see that what we've got here is quite a complicated convex face. And that's fine. It's fun to have these kinds of faces. But what we need to have is a little bit of padding so that we can have our debris elements hook in properly. And to do that, we're going to go and select this giant set of faces. Maybe not this set here. And then we're going to switch over to individual origins, extrude and shrink, and then extrude back. Okay, so you can see that there's a little bit of problems there. That should be fine. What we've got over here is a weird situation. I'm not sure why this ended up the way it did. Maybe what we'll do is just deselect this guy and just do this one face first. Oh, I see the problem. I didn't actually deselect everything. Here we are. So we'll extrude and then shrink, and then we'll extrude back. There we are. And you can see that there are some places where it doesn't quite work, so we'll just keep changing the exact size until the indent works. And then what we'll do is we'll just grab some other area and make sure that it feels like there is something decent going on here in terms of how this works. So, for example, just do this. Now, this is going to be something that gets filled in, so we're not going to have to worry about it too much. But we'll go ahead and just save that. Now, the problem is that I think that this is actually using the mirrored mesh, and I deleted that, so it's going to vanish. No, it's not. Good. So what we're going to want to do is use this guy to, well, let's rotate him so that we can see him in the direction that we're trying to get him at. What we're going to want to do is put some elements on this guy that make his debris look really convincing. So to do that, we're just going to steal them from a place where they already exist. That's this thing here. First, we're going to start with the interior plates. These interior plates are obviously radically different size in this object, but that's just a difference in how they're scaled. It has nothing to do with their mesh size or anything. So we'll just grab this guy and drop him into our grind. I should have shrunk some stuff. There we are. Let's go ahead and shrink some of this stuff. There we are. So now we've got this interior plate. We'll switch it so that it's in the right spot and in the right rotation. There we are. And we'll zoom on over here. Now this is just fill. It's intended to make the interiors look like they exist. And I don't know which way is forward, but I think that this is the back end. So we're going to want to flip it. Yeah. And then we'll just move it and scale it until it is until it feels like it's in the proper spot. And you can see how this just fills in the interior quite nicely. So if we were to scale it down to 0.5, for example, we get this result here. Now what we're really going to want to do is not create a flat result like this necessarily. It might be better to have two of these and have them tilted slightly, but we have another kind of module, so let's grab that as well. And this is the other kind of module. I call it the edge hardening module, and it is just another object that we put into our scene. So you can see that this has a triangular shape, with the idea being that you put it at the edges of the object, and it looks like you have torn a chunk out of the interior, an edge element out of the interior. So if we drop this over here, you can see how that should work. I'm not 100% sure that that is the correct orientation, but I think it is. Now, we have a lot of options for exactly how we want to scale and shape these. One of the things we can do is make this like considerably bigger, or we can have two of them. Now, because these draw in groups, you know, in combined elements, what are they called? Instance. Oh, this actually doesn't have instanced on. We'll turn it on. Since it uses this instancing system, these are able to be drawn in large numbers almost for free, as long as we don't scale them negative or anything like that. So what we're going to want to do is just come up with a solution that looks good, and we don't have to worry too much about using too many of these. I mean, it's better than better to use fewer, but you don't want to use fewer to the extent where you don't get the job done, you know? That's a problem that a lot of people seem to have, is over-optimization. I don't want to use these resources. Well, they're resources for a reason. You should use them. The triangle thingy looks kind of skewed. Well, it is kind of skewed. I changed the scale so that it would be... I guess I can just use the triangle system. I don't really need the interior blocks if I make these large enough to matter. Let's go ahead and try that. Yeah, you can see how big these are, and that's fine, because what I can do is... What happens if I just delete that? Okay, I do need it. Oh, that's fine. So the question is what we want to do at the top and at the bottom, because I can just duplicate these triangles again and put them up at the top and at the bottom, but that gives us a kind of strange situation where the triangles are really deeply embedded. Like you can see how this is going on. So that's not necessarily a good option. I think a better option is to use the debris system. So let's go ahead and grab some debris objects. There are two basic categories of debris objects. There's the hull plating debris object, which is right here, the panel injector. And then there is the free-floating, I didn't get the panel injector, goddammit. Panel injector. And then there is the free-floating one. So we're gonna use both. So now we've got this object in place. We can move it, and you can see what's going to happen based on those markers that you can see glowing there. Now what I'm going to go ahead and do is just grab the core hub, these. I'm going to delete that one. I'm going to just move this one back because it's kind of in the corner of my vision while I'm working. I don't want to delete it because there's lots of stuff left to learn from it, but... Albuechi says he means it just looks like it's on lower on one side as if someone skewed it. Yeah, it's actually built specifically to be like that. It may not be a visual that ends up working, but since it's just a mesh, I can change it later and it will automatically update. I did that on purpose. Whether or not it ends up looking good is another question. So what we'll do is we'll put a panel injector down here on the bottom and on the top. The orientation of these matters quite a bit. But wait, this panel injector doesn't have a mesh attached to it. Hold on. Did I get one of the panel injectors that doesn't have... Is this it? No, that's an interior plate. Come on, it's right here. This. There. No? Oh, is that attached to the hab? Okay, so I deleted something that I wanted to use, but that's fine. I'll just recreate it. It's not a big deal. Basically, those panel injectors should not just be free-floating. They should have a mesh attached to them. So let's take a quick look here. Debris grid injector. That's one of them. Yeah, that's it. So what we're going to do is we're going to drop that grid injector into our object. And it does this exact same thing, but it has a grid attached to it. So it looks better. And you can already see the indicator here to show you what's going on. So what we're going to want to do is move that into position. So the way that it's default set up is to create a grid, delete that, is to create a grid that overlaps with the mesh. You can see how this paneling is on top of the grid. So in theory, it creates a wall. We're actually not going to be using it like that here, though. What we're going to be doing instead is using it to create a projection. So we're going to hide most of the grid inside of the object. And then we're going to just create a projection out of it. But you know what? This grid is a little too big. What we're going to need to do is get ourselves a smaller variant. So we're just going to grab the grid injector object here and create a variant that is half-sized. It's in call large ship, really? I guess it is, huh? I would have thought it would be in a debris file. So the debris injector is right here, and we're just going to create a duplicate. Shift D, there it is. And this duplicate is going to be called a half injector or something. And what we're going to want to do is just delete half of this, and the half we're going to delete is the back half. Well, that didn't work. There we go. That way we'll be able to just use the ragged tips, and that'll look much better. We're also going to go ahead and just delete this loop here because it's a little bit aggressive, and I don't need quite that much aggressive elements right there. So, and then this guy here can go too. There we are. And that should do. Now the only problem with this is that I've opened up a couple of small wounds, so we'll just close them. No biggie. Is this doing a... Oh, it's got a bevel modifier attached to it. That'll certainly create some extra extroverts. I may have to turn that off. We'll see. All right, so now we've got a half. It's going to take a little bit to that's a big file, so readjusting it's going to take a bit. All right, so now that it should have been readjusted, we can go in here and we can change this out for the debris grid half, and you can see how different that looks. Right now it's just rotated wrong, so we're going to flip it around. There we go. And we're going to want to move it so that it suits us, and then we're going to want to save it as a new prefab. So we'll just drag that out here for a second and move stuff so that it matches up. So this needs to be 0.5. Just, that's the math of it. That should be okay. So we're going to go ahead and call this a debris grid projector, since it's projecting rather than injecting debris. And we're going to just change a couple of the settings here so that it is a little bit more aggressive. And then we're going to save that as a prefab. Boom. And now we can just use that everywhere. Begin attack run stopped in. Hello. So if we move this up, what our plan here is, we want this to look like it is creating a tremendous amount of debris. Right now we have a problem where this debris object is simply too big, but that's fine because the panels would have been too big. So if we shrink the whole thing down, it'll look considerably better, according to everybody. Now the only problem with this is that our panels are actually not blue. They are hull-shaped. So the panels coming out of this blue element are not going to be blue. And that's going to be a little bit of a disappointment, but you know, we'll live with it. What I'm going to do is move this into the middle. Hold on, I've got to figure out the best way to do this here. I think, oh, we need to reset this collider here. Let's go ahead and reset the collider in here as well. There we are. Basically, what I need to do is make sure that, first off, snap settings need to be fixed. What we need to do is make sure that the actual blue area covers the entirety of the thing we're aiming to fill, and that's pretty easy. We just adjust the size until it fills. Boom. There we are. And now if we wanted to see this, we can just tell it to spawn, and you can see how that works. So putting aside that weird blue flicker, which is just a HUD element thing, this is how it looks when we create it with these settings. Now, as I said, these are not blue tiles. These are just silver hull tiles, and that may be an issue. We may have to think about that, but we'll leave it for now. We can always change it up later if we need to. So what we're going to do is we're just going to go and have this repeat itself a couple of times so that we have a setup that works for us. Flip it over, and then move it into position down here. I flip it over because it does matter which direction is the top. There's a big difference. The bottom is a little bit different. I can see that I have some stuff in the way here. Where's the... Can I get that? No, it's going to be a little too big. We'll just shrink it a little bit. There. Good enough. And now this can get stuck in... What happened to the actual element inside of the grid? What the hell? The grid went away. Did I somehow delete the grid? Fucking obnoxious. Okay, try one more time. 0, 0, 0, 0, apply. And now let's move this into position again. I have no idea why that deleted the grid, but didn't make me happy, I'll tell you that. I must have done it just, you know, by accident, but it was obnoxious. I didn't like it. Oh, that's not what I wanted to change. I wanted to change. There we are. So there's a lot of options as to how to set this up, but visually I just don't have any blue tiles configured, and I'm not sure whether I want any. I could create some. It wouldn't be hard. But let's go ahead and just start up a variety of units here. You can see this is a slant. Well, there's nothing wrong with that. We can easily slant the entire mesh element like so. We'll reduce the scale back down to 8 or 9 or whatever. Now this actually has a debris grid I want to get rid of. So the other time it got rid of itself, I didn't want it to get rid of itself. But this time I actually wanted it to. I know, brilliant stuff. Everybody stops in to see me mumble to myself about deleting things. So what we need to do is just obscure the fact that this is not a very good panel match. I'm not too concerned about that. It should work okay. I'll grab this thing and move it over a touch more. And then we're going to want to duplicate it and rotate it and make it the side. Now this part does match up pretty well, so we can try and get it to be as nice as possible with the matchup. Go ahead and make this perfectly hit the size that we need. 4.5, something like that. I may have to do a little bit more editing. Yep, I got to do one more thing, because that is causing us issues. Don't know if you could see that or not, but basically we were having an issue where the grid wasn't properly, the box collider was extended quite a bit further than it needed to be. And that was bad. So we'll fix that. All right, so that should be correct. All we need to do is move it into position. I guess it's 9 wide. That's fine. And you can see that there is a little bit of wasted space. We can try and work with that and figure out exactly what we want it to be, but it should be okay. We're not too fussy here. It looks like this is going to be, once again, large enough that 2 is too many. That's a shame. Should I use a different scale, like 0.35? So if I use 0.35 instead, maybe I can fit exactly 2 here. Well, ish. Okay, so here you can see a couple of things. It says contained and raycast for bounces. We're not going to be doing the raycast for bounces, and we're not going to be doing the contained. So we have to select all of these guys and turn that crap off. Because that was me testing something else. So this needs to be considerably longer, on the order of 13. Yeah, that's better. Maybe 12. All right, so just to get a glimpse as to how this looks, well, we're going to go ahead and use one last element, steal one last thing, and that is just the wild debris elements here. These blue boxes are the bounding boxes for heavy debris elements, and so we're going to duplicate one of those and then drop it into our HAB module and move it into position. I'm going to go ahead and drop this into our prefab system, just because we'll need it a couple of times. So you can see that this is radically the wrong scale at the moment. It's this tremendous object. There we are. It's this tremendous object that's far too large. And that's largely because we can control the spray size as we see fit. Now, one of the issues is our crosscut. We actually have been editing this in a really tiny form. I believe that 20 by 20 by 20 is actually what we want. And I was editing it at normal size because I'm just an idiot. So we're going to want to change that snap settings back to 20, 20, 20. And this time we can work with this debris system and make it a little bit more to scale. And so we can scale it like this, as you can see, and it just works. Now the problem is that that will scale the actual debris as well. So it's up to us to decide, how we want this to happen. So the debris system, we can choose how many pieces of debris, what the radius is, the edge fuzz, the spray size, all of this stuff, right? And we can also choose what mesh we want to use. Right now we're using a desk-like mesh with particle debris. I think that the desk-like mesh actually has two materials, and we're only going to be seeing one of them in our setup right here. I don't think the desk-like mesh is what we actually want to use, though. I think that's just left over. It might be better for us to use window panes. Now, I know that the window pane has two meshes, or two materials, because one of them is transparent. So we're going to go ahead and put in the glass material here. Particle debris glass. And just to take a look at how this works, we're going to hit play and see what we see. I deleted the main camera because I am an idiot. Oh my god. The gimbal arm was the camera gimbal arm, not a ship gimbal arm. You idiot. All right, well, let's go ahead and save this as some other scene, and then we'll reload the garden scene and see whether or not we saved over it with a missing gimbal arm. Color, chip shown, particle system, HUD, edit system, edge guides. Hello? Okay, so the gimbal arm still exists in this version. So I'll just grab it, and we'll go back over to our other, and paste it in. Here we are. Now the only problem is that this is incompatible with the ship we've got set up. That's not a big deal. We'll just drop in the pieces that we need here. And I think that should be good enough. We should be ready to roll. I mean, we're inside of the object, but what's a little bit of inside of the object between friends? So here you can see that we're coming around and we're going to see what the debris looks like. Okay, so we definitely have a little bit of adjusting to do. For example, this area here is strange. I don't know exactly why that happened. That's kind of interesting. But you can see what we've got. And one of the issues we've got is that the windows are not being properly painted. That's interesting. Submesh index is out of range. Well, these windows, they should have two submeshes, one of which should be glass. But I used the intact window instead of the broken window. Okay. So let's go ahead and fix things up and try again. First things first, let's go ahead and move this whole thing so that I don't have to worry about going around it anymore. We also need this to have a collider on it, a mesh collider. Come on. There we are. We don't really have any other option. We need to have a mesh collider. That's why I tried to keep it relatively simple, but the problem is it's got like decals and crap on it, so it's that's probably the most heavyweight thing that we're going to have to deal with, the mesh collider for these objects. And let's go ahead and move that out and back a little bit. And the particle system right here. Oh, that's not it. There it is. We're using the window pane, and we should be using the damaged window pane. Is that what it's called? Debris windows. Debris window pane. There it is. And it's also much too large. The scale here is between 2 and 4, and that's obviously not cutting it. So I think we're going to go ahead and make this scale back down to something nice like 111. And then we're just going to go ahead and adjust these values until they fit our needs. There we are, like that. Even that's a little bit big, isn't it? We'll just keep shrinking it until it's the right size here. Like that. That's fine. Gimbal arm crisis averted. Yep. And then what we're going to do is we're going to change this max and min scale to like 0.5 and 1. And we'll save and hit play. Bum, 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 bum. I think this is it. So, that's interesting. Maybe I made it with the intention of using large numbers because it's all clustered up in here, and that's not really how it's supposed to look. Oh, okay. Well, there are a couple of things wrong. First off, none of these are lit properly. You can see how they're popping in and out like that. In theory, I know what causes that. I can't remember what it is. However, the other problem is that the LOD system is all screwed up, and it's deleting and recreating them. And that's probably because I changed scales and sizes and stuff, and it's quite confused. But you see how you occasionally see that glimpse of blue, and sometimes you don't? See that blue down there? Now it's gone again. So there's definitely something wrong with the rendering. It's not rendering the second material even when it should be. And that's probably just something I screwed up with when I created it. So we've got a problem where the level of detail stuff is not working correctly. And also it looks like the x-axis or the y-axis is all screwed up in terms of being much, much smaller than it's actually indicated as being. And that might be me forgetting to allow something to go negative. Okay, well now I can't see it at all. Okay, come on. Can I do this? Okay, so I can't just do it in scene view, but I should be able to see it here, and I can't. So argument cannot be null. Can't find a surface for debris system to project onto. Oh, wait, am I doing this backwards? I think I'm doing it backwards. Give me a moment here. But first off, what is this can't find null? Argument cannot be null. Here we are. A is less than materials dot length. Draw mesh instance to mesh materials A. In theory, the only things that could be zero there or empty there are the materials and the mesh. So either I forgot to put the other material in for some reason. Oh, look at no, that should be fine. Yeah, that should work. But what I'm going to do is pull it forward like this. And once again, we've got a problem where it's not finding the collisions that it's trying to find here. Might take me a little bit of time to get used to this again, because I was using some magic numbers, and that wasn't really very bright. It should mostly work. It's just that for some reason the LOD stuff is barfing, and it's not finding anything to project onto, which is really weird because what it can project onto is this entire surface. Not only is the object itself colliding, it also has these massive interior blocks that have colliders attached. So the idea that there is nothing to collide with is very silly. Well, if we take a look at the particle systems over here, here's one of the debris systems, and it is that guy. And as you can see, it's not lined up inside of the object. It has nothing special going on here. Don't really see why that would work and this wouldn't. Unless it's because it's rotated differently, but that shouldn't have any problems. Could it be because of the mesh collider? Well, I mean, it should be able to find the mesh collider just fine. Mesh collider is, all of these things have colliders on them. So there shouldn't be any problem with it finding something to collide with. The question is why it's not. But I'm also worried about this argument cannot be null. Something here is coming up as null. And I don't know what it could be. In theory, it could actually be the wrong... Let's go ahead and just turn these guys off for now. Maybe they behave differently. Yeah, well, the problem is that I actually stole these straight from the other module. So if they worked for the other module, they should still work now. All I did was change their scale slightly. Now, I do have it complain if there is any sort of, if there's very much missing. It says that it misses, but it's clear that it's missing everything here. And it's also got this argument equals null, which is truly strange. We're going to go ahead and put in some debugs and try and figure out what the heck is going on. Elbow just said, do not say that all you did was change their scale. Yeah, we all know what changing scale is like with this setup. If materials A, we'll just go ahead and debug. Debug.log, hold on. Yeah, debug.log materials A. Let's see whether or not it's a material problem. I don't know why it could be. It could also be that there are no objects. Because if none of the objects get spawned, that's probably what it is. It's probably just that there's no objects getting spawned, so it's like whatever, right? We're going to go ahead and add in Alboetchi's fondly remembering the way that the debris was just always screwing up when we had that scale problem. Spray size is vector.1. All of this stuff should work. What I'm going to do is add in a number that we actually used. So this number here, for example, we're going to change that to be the number that we actually use when we spawn this in. So if it's 0, I'll be able to tell. Okay, so here it says physics.raycast, negative transform, out hit radius. There's no specific limit on which layer it's hitting. Here we can see that the error, it just subtracts 1, so it should still be... okay, so... Alboetchi says that people will never forget his misspelling of the word debris. Let's go ahead and make this 100 or 1,000. It can't be lower than 1,000. But what is going on with it failing? Because it only complains about it failing if it fails more times than it tries to succeed. And it's not doing jack shit. Okay, so what we're going to do is we're going to create a new debris system and move it to somewhere else. Hide this thing. Create a box. Game object, 3D object, cube. Scale it up. Boom. And boom. All right, let's give it a shot. Oh, for free. I accidentally created it in play mode because I'm an idiot. Okay, we're going to hide this. Paste in that cube again. Duplicate this debris system again. There we go. Now let's try it. Okay, so that didn't barf. And there are all of our objects. So you can see that what happened here is that they did not go out into the depths of space like I, for some reason, thought they would. Instead, they're all clustered right here at the collision point. For some reason, however, that would indicate that the colliders weren't working for the other object, which doesn't make a whole lot of sense because, I mean, and we still have a problem with the LODs. Okay, so one of the issues is that our LODs are all screwed up. But another issue is that these are really sticking to the surface. Okay, so I'm trying to think. I did this so long ago that I don't remember very much about it, and it may actually be faster to just do it again, because it's very, very easy to build, and it's clear that I did something specific and just forgot some kind of thing and ended up making something super fragile. And I don't know what that super fragile thing is. But here you can see the problem is I've got this LODify and it's malfunctioning. And so I've got another problem, and that is that all of the objects are clustered at the collider rather than, you know, spraying outwards. And there's no like argument to let me change how they spray or anything. So what we're going to do is we're going to create a new instanced system. We need to have a master draw instanced manager anyway. So maybe that's what we'll do right now. We'll create a new draw instanced controller. It's under graphics. We're going to want to create draw instanced manager. And then there's just going to be one of these guys. We'll attach him to the camera or something. It doesn't really matter. We'll put him on the sun. So the draw instanced manager is going to have a public static draw instanced manager live. Can you please start the autofill for me? And then we're going to go and awake. We're going to put in live equals this. Liver, yes. We're going to check and make sure that live is not something else. Debug.log to log error to draw instanced managers. New one replacing old one. Named live.name. All right. So what we need to do with this draw instanced manager is we are going to take in a huge list of meshes and stuff to draw. In order for this to work, we're going to need to have a new kind of thing. And so we're going to make that into either a class or a struct. It doesn't really matter. We'll make it a class just for the sake of doing things. We're going to call this a draw instanced instance. And this is going to have to be a system.serializable. And what this does is it takes in a mesh and a couple of materials. And it also takes in a giant list of positions and locations and all that stuff. So public, come on, public vector3 array scale, position, and a public quaternion rotations. And lastly, we're going to have a public matrix 4x4 of matrices. And what happens is these things can get called public void draw. And we'll want to draw them to the screen using the exact same draw instanced system that we were using before, which is this thing here. It's very, very basic. Sorry, that's not it. It's this thing here. Is this very, very basic setup, right? Now, the problem is that this setup doesn't actually have any LOD elements in it. So we're going to need to have it have LOD elements in it in the long run. For now, we're just going to go ahead and draw it straight, okay? So what we do is we go through the materials, and I'll say material M equals materials A. And then we're going to also go through all of the... oh, you know what? If we make these a flat 1,000 each, we won't have to worry about that. And there's no reason not to, right? Yeah. So we're going to go ahead and just draw all of them, assuming that there's no more than 1,000. And we're going to go ahead and note that in 1,000 or less things to draw. So we've got materials.length, we pass it in, and we pass in this LOD objects, which we're not going to be doing. We're going to be passing in matrices. And then we have mathf.sealed.int, and that's going to be just the length of matrices. In the material property block. Okay, so we are going to have to take in a material property block, I think. There we are. And the shadow casting has to be either on or off, so we'll go ahead and public bool shadow cast, and we'll just pass that in. Oh, I guess we can just... Sorry. If shadow cast, then do it one way, otherwise do it the other way. I mean, I think there are easier ways to do that. I could do maybe an inline. Can you do it inline? Let me check. Let me go ahead and try and do it inline. I generally avoid this because it's hard to read and therefore hard to maintain. Shadowcast question mark. On. Why isn't it letting me? I guess this is probably illegal then. Let's go ahead and see if it's illegal. It actually doesn't register as illegal. Fascinating. Well, we now have this set up. So we're also going to go ahead and just put in a quick little if statement. If matrices.count is greater, matrices.length is greater than 1,000, debug.log warning more than 1,000 meshes in a batch when drawing, and then mesh.name. And that'll actually barf. It won't work right, but that's fine. As long as there's an error explaining why it barfed, I'm happy. So this means that what we can do is just create a tremendous number of these instances in batches of 1,000. And then we can control when they get rendered and at what distances and all of that stuff. But these draw instance, they do not have at the moment a bounding box. They don't have an LOD system set up for them. We're going to add one later, but I don't want to do it right now. But the key to this setup is that anything can throw new meshes onto the pile. This doesn't have to be a situation where each game object handles its own rendering. And that's important because we're going to be passing in a lot of different things. Do I really want to do it like this? Okay, so draw instanced is a very specific thing where it creates all of the objects and also determines where they're supposed to be and also creates the LOD stuff and also does this and that and the other thing. I was thinking about replacing that with a generic overall manager, but maybe that's not a good idea. Yeah. I was going to do something smart, but it was too smart and not actually functional enough. You got to make sure not to overdo your stuff because it'll make your stuff harder to manage. So we're going to go ahead and do this in a slightly different way. We're going to do this with a draw instanced base. And the draw instanced base will handle all of the basic features that we need to draw instanced objects, and then we'll descend from this rather than using a core manager. Draws meshes with LOD elements. Now, the issue with this is that the setup that we have for creating all that stuff is going to be in another class. But basically, we're going to grab all of the same setup here and put it into this instead. But we don't care about everything. We only care about certain objects, certain things. All of these, for example, we need. I have a feeling that this is not the best way to do it. Was I sick when I made this? Because this code looks a little bit dumb. So Unity actually has something called an LOD group. But the problem is that the LOD group uses integer values like 0, 1, 2. And that's actually not what I need. I need something much more smooth. Unfortunately, I'm not at all sure that the LOD group... It's not called LOD group. It's called something else. It's called culling group. Yeah. So the culling group, I'm reading off of the screen here. So the culling group you just use a bunch of spherical bounding spheres. They're obviously going to be spherical. And it will check on all of these spheres, and it will have different sorts of callbacks if the spheres have different levels of visibility. And you can check and see the distance band, but I don't want the distance band. I want the percentage of the screen it takes up. Now, the reason it does the distance band is because when the distance band changes, you get an event. And if you had like a giant stack of, if you had one every frame, that would be pretty slow. But the basic idea is that it calculates every frame whether or not something, what the exact situation is. And then it only gives you events on the frames when something changes. Wonker says, "What do you mean smooth? Like blending in between two meshes?" No, sorry. I'm talking to myself kind of just off the cuff, so I didn't explain it. I have tens of thousands of objects, and what I do is I have 1,000 units of large scale objects that I use when we're far away. And then I've got another 10,000 or so units of smaller objects that I use as we get closer. And so what I do is I actually use fewer and fewer of the large objects and more of the small objects as our distance changes. And it's a very smooth transition. You probably never notice it. So I want to keep that going, but it doesn't look like I'll be able to do that with the culling group. It might be worth trying. Let's just go ahead and investigate. Culling group. Cull group equals new culling group. And what we're going to do here in start is just take a quick little look at what we've got in here. So we've got dispose enabled, erase swap back, erase a bounding sphere by moving the final sphere on top of it. Get distance, guess the distance band, set bounding distances, accept the bounding distances for the distance bands. I mean, I could just give it like 10,000 bands. Okay, so there are a couple of things here. This uses target spheres. And you can't even get the spheres. You can set them, but it's fire and forget. So once you've set this thing up, it just runs on its own. Retrieve the indices of spheres that have particular visibility. Oh, that's an interesting idea. So what I'm trying to figure out is whether or not it's worth using this. I actually don't know how to calculate whether or not a sphere is on screen. I know how to calculate whether or not it's in front of the camera in terms of z-axis, but I don't know how to calculate whether it falls within the frustum of the camera's view. So the question is whether or not there is another way to check that. So here you can see you got the camera, this is the calculate frustum corners. And this creates corners, but they are, so I don't understand how they work. There doesn't, what I really need is, can I submit a sphere to the camera and see whether or not it's on camera. Layer cull spherical, how to perform per layer culling for a camera. I actually don't know what that means. Per layer culling distances. So this is a getter and a setter, but they're not really telling me what it is. So let's go ahead and look it up. Let's go on over into Unity and punch it in. Layer cull spherical. Normally, this type of culling is performed by moving the camera's far plane closer to the eye. By setting this value to true, the culling is instead based on spherical distance. Okay, so that's actually not what I need. Okay. Yeah. I don't really see any hint that there is like a built-in is this sphere on camera option. Let me just do a quick little search and see whether or not Unity has a built-in function for that that's not limited to the culling group. Unity is sphere, in camera. Camera movement on a sphere, spherical movement with cameras, camera, sphere, follow in frustum. Geometry plane, test planes AABB. Will return true if the bounding box is inside any of the planes. And the example is you get a camera and you get the frustum planes of the camera, and then you get the bounding box. This is actually exactly what I need. So this is test planes. I wonder whether there is a non-planar. I think this is bounding boxes. I wonder if there's a non-bounding box situation. Let's try it out. Geometry utility dot calculate frustum planes. Calculates frustum planes from a camera. Okay. Test plane ABB. Okay, so here an update. We'll just grab those frustum planes. So geometry utility dot calculate frustum planes, which is a plane array. And we'll pass it the camera. And then here we'll just go ahead and in start we'll say camera equals camera.main. And then we're going to go ahead and use geometry utility dot test planes AAB. I guess that's the only option we've got. We can get the bounds by passing it a whole bunch of positions and a transformation matrix, which, funnily enough, we actually have a whole bunch of positions and a transformation matrix. We could just calculate the bounding box like this. We may want to fix this later in terms of caching it, but for now we're going to just go ahead and pass it all of our positions. And then it's going to be a quaternion.identity. And then what we're going to do is say geometry utility dot test planes AAB planes bound. And that should return a Boolean value, right? Yeah. Bool visible equals, there we are. This will determine our visibility, and if we're invisible, we don't want to draw ourselves. Obviously, right? So that's just wasted time if we draw ourselves there. So here we'll just say if we're not visible, then return. We're going to go ahead and actually have visibility be a public value just so that we can see it. And we will set this. That way when we're debugging, we'll actually be able to just debug it. So there are a couple of things here that are not ideal, and we're going to go ahead and immediately fix one of them. And that's going to be the, we're going to cache the planes as a static value. Public static time. Can we cache time? I don't think we can. Is it date time? No. Int? I don't care. Let's check and see what it is here. Time dot I guess these are all floats. Okay. So public static float last cache time equals 0. Public static plane cached planes. Down here we're going to say if last cache time does not equal time dot fixed time, then we will want to set this up again. So last cache time equals time dot fixed time, and boom. We will cache the bounds individually for each object. So we'll do that here. So we're going to need to do a lot of stuff here. Public void spawn. This is going to have to be a virtual void spawn, I guess. There we go. And bounds is going to have to be a protected bounds. There we are. We can make it public. Why not? We'll make it public so that we can debug it. So right now the problem is that we're not actually creating any anything here. We're just telling it to get the bounds of nothing, which should be valid. We should get back a null answer for that. But what we can do here is use cached planes and the bounds. If not visible, return. Otherwise, debug.log drawing and then the name. Yeah, that's fine. So what we're going to want to do here is just take a look at all of the errors we've created. So this didn't like it at all. Pos is a vector3 array. There's the vector3 array. And then there's a matrix 4x4 transform. Okay, so I was supposed to pass it a matrix 4x4, not an identity, not a quaternion. So there we are. We'll just use the matrix 4x4 identity instead. There we are. Cached planes does not exist in current. That's because I spelled it wrong. Debug log because I spelled it wrong. Doing all this stuff wrong. And have you got anything else for me? All right. So here you can see the value of planes is assigned but never used. That's because this is supposed to be cached planes. All right, that should do. All right, so this setup right now draws when we're on screen and doesn't draw otherwise. Now the problem is that our bounds are calculated based on the positions that we have in memory. And right now there is no position in memory. So we're going to need to create just a temporary class specifically for testing this stuff. So draw instanced simple. Inherit from draw instance base. And what we want to do is just override spawn here. And before we call the base.spawn, what we're going to want to do is actually populate all of those values, at least the positions. So for that, we're just going to go ahead and create a sphere of whatever radius, public float radius equals 10. And we'll just do 1,000 of these. So for int a equals 0, a is less than pos equals new vector3 1000. A is less than pos.length, a plus plus. And we'll just go ahead and say pos equals random.onUnitSphere, like that. And then we will tell it to spawn the base. Now, we're not telling it to draw anything right now. It doesn't actually have any functional drawing elements. But what we can do is have it determine whether or not it's on camera. Yeah, there we are. So we're just going to create a gizmo here. Public void on gizmo draw or on draw gizmos. On draw gizmos. Gizmos dot color equals color.red. Gizmos dot draw sphere. Draw wire sphere, I guess. Transform.position radius. And we're going to want to actually put that into the game world here. So this thing, we're going to go ahead and delete the debris system we've got in place. And we'll just create a new object here and add in our new simple drawer. Boom. You can see how it is barfing here. Cull group equals new culling group. Okay, so it can't actually do the culling group. We're not using it, so who cares? deleted. I think that was just an old error. I don't think it's a real error. But you can see that we've got our drawing field here. So what we're going to do is we're going to go ahead and see if that visible on camera thing shows up properly. So you can see how it says that it's visible on camera, which is true because it's right there. And as we continue to turn, it should turn off. It didn't turn off. Oh, it did. Hold on. I actually don't know whether or not that's working. So you can see that right now it's not visible on the camera, but that may be true. No, now it's on the camera again. So it's right in the middle up against the plane. It should be on. It should be visible on the camera basically all the time. But it should stop being visible as soon as we turn past here. Okay. It seems to be working. I think it's working. I'm not 100% sure that it's working. But I think it is at least mostly working. So, oh, we can actually check the bounds right here. Hit play, and we can see what the bounds are. The center is very close to 0, which is a little bit odd because it shouldn't be. It should be very close to negative 0.77. And the extents are 1, 1, and 1. Okay. So the positions didn't actually, I forgot to add the, hold on. I forgot to add our position to them, which is Y. That should do. And we're going to want to multiply this by the radius. That's probably why I was getting some slightly weird readings, because it was not quite showing up right. But now it should. Okay. Yeah. So we're not drawing them yet, but we are testing to see whether or not they are visible, and that seems to be working. Yeah, so that should work in terms of keeping them visible or invisible, and it's substantially cheaper than the other way I was doing it. I actually don't know if it's substantially cheaper, but it's substantially more accurate, and also draws more correctly, because the other one would draw even if they were off screen. So the draw instance simple, we want to create all of the things that we're going to need. And that includes the other objects, rotation and scale. So rotation equals new quaternion 1000, and scale equals new quaternion equals new vector 3. Yeah, vector 3 1000. And we'll just fill those in. Rot A equals quaternion.identity. And let's... and scale A equals vector 3.1. And over here in draw instance base, we need a couple more things. We're going to need to know public mesh and public material list materials. And that should allow us to actually draw the things that we're trying to draw. We're also going to want to do something about this. I haven't really decided what we want to do. I think that's probably correct. Each of these matrix 4x4 arrays is 1,000 long or less, because that's the maximum that we can send over at once. So it's a list of up to 1,000 units. It's a list of packets of up to 1,000 objects each. And we're going to want to fill that out. So we're going to go ahead and create a function to fill it out. Public virtual void fill out object list. And what we'll do there is we will just grab all of the objects and set them up. So obj equals new list of matrix 4x4s. And then we're going to just actually clear it, obj.clear. And then we're going to go through, and for every 1,000 objects, we're going to fill in a matrix 4x4. So for int a equals 0, a is less than pos.length, a plus equals 1000. And then we're going to go through here for int b equals 0, b is less than 1000, b plus plus. Am I doing that backwards? I think I'm doing that right. That's right. Yeah. And then what we're going to do is just a plus b is inside of the matrix. So matrix 4x4 blob equals new matrix. It's an array of 4x4s. So right now I'm saying 1000. It's actually not 1000. Int len equals pos.length minus a. If len is, I'll go ahead and just mathf dot, no, not even mathf, just if len is greater than 1000, len equals 1000. There we are. And that way we won't have to worry if we do fall short of the 1000. B is less than len. And we say that blob a plus b equals matrix 4x4 dot trs, pos a plus b, rot a plus b, and scale a plus b. And that'll get us a list of all of the objects. Now we have a special set of objects, which are the LOD objects. I'm not sure what I'm going to do about those for now. We'll just go ahead and delete them for the moment. We'll come back to them later because we do need the LOD objects. Otherwise, things will look terrible. They'll glitter, and we don't want them to glitter. Not on accident. We might want them to glitter on purpose, but... So here in the spawns, we're going to go ahead and call this fill out object list right here. And we're going to want to put in a comment here. Override this, but always call the base function at the end so it can fill in the details. And now what we're going to want to do here in update is actually draw all of those things. So for int a equals 0, a is less than, we'll just do for each. For each matrix 4x4 array blob in, I forgot to add it. Just yeah. I actually need to add the blob correctly. Obj dot add blob. So in here, what we're going to do is we're going to pass it that one function that draws it. And so we'll just grab that function here. Blob.length. MPB, I don't have one. I think that I'm just using an empty one, and there's no reason not to just keep using an empty one. All right, so right now we're going to be drawing them without shadow casting. Let's go ahead and do this. To do shadow cast LOD. Put in some notes there just in case we forget. But that should actually draw all of the things that we needed to draw. Do we have any errors? No, not really. So we're going to go ahead and take this and put in the mesh and material that we would like to use. And that's going to be the debris window pane with two materials, which are going to be the prox debris, particle debris, solid, and particle debris glass. There we go. Save this, and now we should see 1,000 of them. It is a ball of black. They shouldn't be shaded. Ah, there we are. Perfect. So you can see that we now have the functionality we need. We have a ball of dark energy. And as we go off to the side here, and we push past, we will see that it turns off. On the far right, you'll see it turn off the instant it leaves the camera. Boom. And then when we turn back, it pops right back on. Seems to be perfect. Now, when we get far enough away, it renders as black, but that's a shader thing that I put in specifically because it's expensive to draw these things in shadows at range. So when we're far enough away, we actually just render them as black, and that's our version of shadowed. So when they're far away, we say draw them unshadowed, but you're going to be drawing them black, so it doesn't really matter, right? That's the basic idea. And we're going to want to have them draw with shadows if they are within the shadow range, but only if they're entirely within the shadow range. If they are partially within the shadow range, then we're going to have an issue where it chops them awkwardly, and they're not going to batch properly. So to calculate whether or not they're within the shadow range, we need to determine the bounding box, the furthest point from the camera of the bounding box. And I actually don't know what the fastest way to do that is. Furthest point on bounding box from camera, question mark. And we'll just go ahead and say bounds dot closest point and furthest point. There is no furthest point. You jerk. Well, we can just get the closest point and then take the maximum size of the box, and that should work. So we'll just take the closest point to the center of the camera. Vector 3 delta equals bounds.closest point, and then we'll just go ahead and say delta, or float range equals delta.magnitude plus bounds.magnitude extents.magnitude. And then we're going to want to have a value that can change. So public float shadow range equals 200. I don't know what it actually is. 200 is a fine way to start, though. We'll say if range, we can actually do that in here, can't we? So again, we'll just say range is less than shadow range, question mark, this, but on or off. And that way we will we'll actually render the shadows properly, in theory. Now, keep in mind these never cast shadows, they only receive shadows. But they should now properly receive their shadows, and they should still be in the dark when we get close. They are not. They should be in shadow, but they're glowing like beacons. I wonder whether or not they are currently in shadows. So public visible on camera in shadow, or shadow casting, a shadow receiving. I'm going to go ahead and put this out in shadow receiving. What did I barf here? What? There it is. Alboy just says, that's a hell of a lot of code. The Darkest Apple says, this looks like a pretty cool project. Well, you're seeing it at its worst right now because I'm replacing one of the core rendering pipelines. And that means that I'm just throwing up a couple of meshes to test something. If you want to see more of what it looks like in earnest, there are better videos you can watch. But why don't I go ahead and just take a moment and toss up one of the HAB cores that I'm using and take you on a quick little tour of what this looks like when it's actually on. So this is one module that got ripped open, and the whole point is that this sort of thing gets rendered very fast and very easily. So you are able to have really, really detailed, complex debris fields, and they're even physics-based. You know, you can bounce off of them and stuff. although these ones are turned off at the moment. And it's all generated, so it's always going to be a little bit unique and a little bit more interesting and fun. And the basic idea is that you can scan damaged stuff and take parts that still exist, any parts that are undamaged that you want to salvage, and make yourself a steadily better ship. Yeah, those physics have been turned off. That's fine. But when you are inside the mess, it looks like this, which is kind of cool. You got this really, really dense field of debris. Yep. There's actually a lot to it, but that's all I can show you at the moment. The Darkest Apple says he only started programming for games a couple of months ago. And this looks interesting. Yeah, I think it looks interesting. That's why I'm making it. Not to be too stuck up my own ass or anything. So let's go ahead and just take a closer look at this. There's something screwy going on. In theory, this should be rendered with shadows. Oh wait, is the sun over there? I'm just an idiot, aren't I? Where's the sun? No, this is in the shadows. The sun is clearly putting this side in shadow, so these objects should be in the shadow. We shouldn't have any ambient light on them at all. But for some reason, when I enter into shadow range here, like so, oh well, actually I'm still not in shadow range. That's interesting. I may have to think about that, because now it's got a radius that's larger than the shadow range. Yeah, so you can see that these are not properly in shadow. And that might be because I'm using the particle debris. This is the debris shader, and the debris shader might actually be optimized to not use shadows. I can't remember. Anyway, we'll deal with that later. For now, we'll just keep on moving. We've got some more work to do here. So we have this generic method of creating these objects, but we don't have any LODs built for them or anything. So we're going to go ahead and start with the LODs at this point. Now, there are two basic things with an LOD. The first is you want to decrease what you're drawing, but you don't want to decrease the volume of what you're drawing. So you want to decrease the complexity, but not the volume. When you're drawing random crap, you got this issue where decreasing the complexity also decreases the volume, because you're just taking like dots out of the sphere you're drawing. But we'll start from there, because that's easy enough to start with. Alboicha says, maybe it's the render queue again. Actually, I didn't check that. It shouldn't be, though. I don't think I've changed anything there. It's at 2000. Oh, you know what? It is the render queue, because this material is not compatible. It'll probably render correct now. Anyway, what was I doing? I was going to go ahead and calculate out an LOD element. So we're going to go ahead and just decrease the number of things we're drawing based on the distance from the camera. So float range value. And this is going to be delta.magnitude, but we're going to divide it by our radius. We don't have a radius here, so what we're going to actually want to do is divide it by our bounds extent. There we are. So if range value is less than 1, then we are actually inside of the situation. If range value is greater than 1, we are pulling back away from the object. And the higher it is above 1, the less stuff we want to draw. Let's go ahead and make it out of 100 just for starter's sake. So range value, if range value is less than 1, range value equals 1. Alboy just says, so the shadows weren't working because the material couldn't cast any shadows. I'm not sure, but I do know that we were having a problem with the queue setup with the default material, because the default material's queue is 2000, whereas this material's queue is 2001. And that actually was a big deal before. If we hit play, we'll probably be able to tell pretty quick whether or not it's working. Yeah, you can see that the shadow casting is substantially better now. Maybe. Yeah. No, it's still bad. Not sure. Anyway, we're going to go ahead and say that range value equals 1 divided by range value. And if the range value is 100, that'll leave you with 0.1, and if it's 10, it'll leave you with... sorry, if it's 100, it'll leave you with 0.01, if it's 10, it'll leave you with 0.1, etc., etc., etc. I'm going to go ahead and make that range value times itself. No, the opposite. Sorry, I'm thinking about the best way to do that, because what we actually want to do here is we'll just go ahead and make it into a range value equals mathf.lerp. 1, 0, range value divided by 100. So that means that if it's a range value of 100, we're going to get a 0, and if it's a range value of 1 or less, we're going to get something very close to 1, right? And so then what we're going to do is we're going to go ahead and get a maximum number of objects we can actually draw. So max obj equals range value times pos.count, our length. And what we'll do is we will cut it off early if we decide that that the max objs have been exceeded. So max objs minus equals blob dot length, but that actually goes at the end here. And in here, what we'll do is instead of blob dot length, we'll do min. Is there an integer dot min? Yeah. No, that's an sorry. It's the problem is mathf.min is well, I guess it works. It casts it to an int properly. There we are. And that will slowly decrease the number of things we draw. There we are. So with this on, we should see that as we back away from it, we draw less and less objects. So there is how it looks now. And as we back, not really seeing any difference here. Nope. Debug.log max objs plus max objs. So for some reason, we've decided that we're not going to actually be at the bottom of the message queue. So here you can see that our max obj is 988. And if we back up, it should start to decrease, but it remains at 988 the whole time. 988 is not what I want it to be. 988 is valid, but it's not a great result. 988 is what we get when our range value is 1, I'm pretty sure. So delta dot magnitude. So delta dot magnitude gets the closest point. I guess we'll just debug more stuff. Delta debug.log delta. Okay, so you can see that the delta is steadily changing. And as we back up, it's not changing. So the closest point is always going to be... Oh! That's the closest point, not the delta. The delta would be our transform.position minus the closest point. You idiot. Just me being stupid, that's all. Now we're going to see it decrease. So rewind. And we should just start to see them vanish. I don't see them vanishing. They might be vanishing now, but I can't tell. Let's go ahead and put that debug back in. So right now we are having a max obj of 1000. Let's see if it ever decreases. I'm doing some integer math, and that may be just what's causing the issue. It's still 1000, and it should be pretty clearly not. So this isn't actually producing any good result here. Range value times float pause dot length maybe. So debug the range value, debug.log range value. For some reason my nose is now giving out. I hope you don't mind that. So our range value is 1, which means that there's something stupid going on. So let's put that above the lerp. All right, so you can see how this has a range of 0.82, which means the closest point is within our setup. And as we rewind, the range goes up very slowly. That's strange. I mean, that should be... Our range should be a lot higher than that. So there's something wrong with our range calculation. Is delta.magnitude divided by bounds.extents.magnitude? So delta.magnitude is our camera transform. Oh no, hold on. This isn't the camera transform. I'm just a frigging idiot. Apparently my brain turned off at some point, guys. I don't know if it'll come back. Oh, that's better. Better. So now we should start to see it decrease. Yeah. So it's not decreasing fast enough, but it is decreasing, so I know I can just adjust it. It's no longer just wrong. So what we're going to do is we're going to divide it by 10 instead of by 100, and that should result in something that's a lot more viable. We may make this a... yeah, you can see how they're vanishing. Yep. That's working correctly. So what we're going to do is we're actually going to square I was going to say something, but my brain stopped working and now I can't remember what I was going to say. We could make it an animation curve so that you can control how fast these fall off. But I think there's probably one right answer. Elbowicha says, so now we've got a much smoother LOD system than before. Not really. What we have now is one that doesn't have a lot of magic numbers in it, whereas before we had a lot of magic numbers. However, what we're missing are the level of detail heavy hitters. So we're going to put those back in, because the other half of this is you don't want to draw less. You want to draw less detail, but you want to make sure that the same amount of space is filled. So we're going to go ahead and create a new array, protected matrix 4x4 LOD objects. And the LOD objects are just going to be the first 1,000 objects in the queue. We'll do that right in here with the fill out object list. And we'll just go ahead and say LOD objects equals new matrix 4x4. And then we're going to either have 1,000 of them or our pause length. So pause.length or 1,000. So mathf dot fewer. What's the fewer? Smaller min. There we go. And then what we'll do is we'll have this exact same setup, except that we are just putting it straight into LOD objects. So what we're going to be doing is we're going to be using the exact same but the scale is going to be 3 times or maybe even more, so that it'll actually show up at range. And then down here, what we're going to want to do is, as we lose objects off of the detailed side, we're going to want to do the opposite and draw more objects on the LOD side. So max objects is going to equal 1 minus range value times float LOD objects dot length. And then we're going to have the exact same setup. So, but we only need to do one call, which is nice. So we'll pass in here materials dot length mesh materials A, and then instead of blob, we'll do LOD objects. And we're only going to pass in the max objects. And now the fun thing about this is we don't have to worry about whether or not we're shadow casting, because we're always not shadow casting. There we are. What is this final value? False. What's that? Receive shadows. Okay. So the reason... Idiot. So this is always going to be off. This is going to be the shadow receiving. So the reason that we weren't receiving shadows is because I was doing the wrong thing. I was telling them to cast shadows instead of receive shadows. All right, let's go ahead and see this now. So what we should be receiving at this point is a few of the larger objects should pop in as we back up. We should be getting them now, but I don't see them. Let's go ahead and put in the max objects down here and see how many of these we're actually getting. Yep, Alboechi, it is always just stupid stuff. That is, in fact, game dev in a nutshell. So right now we've got negative 900 LOD objects, so there's obviously something dumb happening here. The range value is lerped between 1 and 0, and then we multiply it, so it should be between 1 and 0 this whole time. I'm not sure why the range value would give us a result. Oh. As always, it was something dumb. Okay, so now we are drawing a couple of them, a couple of the large ones. And as we back up, we're going to draw more and more of them. Now that's probably the wrong ratio, and I'll probably have to change that But the point here is that we should be drawing more and more of the large ones and less of the small ones. But they don't really look very large, do they? So I scale times 3. It didn't seem to actually have any effect. Yeah, Boichi says he recently spent 40 hours trying to fix a link error. Yeah. Ah, so there. You can see that right there? That is one LOD object, and there's only one being shown right now, which is kind of weird considering we should show 97 of them. So why is there only one getting shown? The only thing I can think of is that I must be using the same one over and over and over. A is less than 0. A equals 0. A is less than the LOD object.length. A plus, there is the problem. I was adding 1,000 instead of 1. So the result was that I was giving it a ridiculous result. Now, that LOD object is not the same. It's not the same level of detail that we're going to want. We're going to want to do something very different with it. But you can see that as we back up, we draw these giant blobs of LOD larger objects. Because there are fewer larger objects, we have no problem with keeping the volume the same. Now, we got a couple of issues here. For some reason, they are once again popping up on top of my my list, which is something I thought we'd fixed. So if I look at the debris here, yeah, it's definitely fixed over here, right? Yeah. So for some reason, maybe I am using the wrong materials? Yeah, so these work fine, but the same draw call on the other side actually barfs, and it's probably because I'm using different materials. So let's take a look here. What material are we using for our buddy? Debris system. We're using particle debris solid, and that's it. Whereas over here, we're using particle debris solid and particle debris glass. Nope, none of these matter. Not sure what mesh fader actually does. I think that actually just repaints the mesh verts. It's been a while since I've had to use that. But these render fine, and the ones we're using over here render weird. That's annoying. Well, let's go ahead and take it down to just 1 and see whether or not it is a problem based on which material it's rendering. Nope. Nope. I still have the same issue here. Is it a problem with it being a shadow receiving? Cody1712 says, hi. Hello. Welcome to the party. So if it's a shadow receiving bug, then when I back away, it should vanish. Yeah, so the big objects are still in front here. You can see that. That means that it's not a shadow receiving bug. What is the issue here? We're using the same material in both places. There's no script execution order difference. There's a shadow range difference, but I don't think that's the issue. This can't be something stupid like it's the mesh, because the mesh should be fine either way. Particle debris solid is the same on both sides. But I can change the mesh just to see. Is it deskish? What? This mesh works. What? It's just a different mesh. Oh, I bet the mesh has mesh colors in it. I bet the verts are colored. And the verts aren't colored in the other one. I bet that's what it is. Wow, that's obnoxious. Okay. Super weird. Apparently certain meshes pop up on top of your visuals and other meshes don't. Certain meshes pop up on top of the HUD and other meshes don't. How bizarre is this? Whew. Weird stuff, guys. Weird stuff. All right. So we're going to go ahead and just use the desks for now. We'll switch them over to something else later. But we need to change these LODs. So what we're going to do here is we're going to change the range value. And we're just going to do the mathf.lerp again. But this time it's going to be 0, 1, and range value minus 0.5f. 2 times range value minus 0.5f. Which should mean that they don't start to come in until we're sufficiently far away. Nope, that's definitely the opposite of what I wanted. Oh, it's definitely the opposite of what I wanted. It sounds like Elboechi's about to start complaining about Unity, which is one of my favorite pastimes as well. Well, you have to realize that I'm working with some extraordinarily cutting-edge stuff that was only put in very, very recently. So I'm not too surprised that there are weird things going on. No, wait, this was correct. So there's something stupid happening here. Range value minus 0.5f. Just to see whether or not this even works. I think that what's going on here is that the meshes have different vertex colorings. This mesh has a vertex coloring, I think I painted it all white, whereas the other one does not have a vertex coloring, and therefore I think it is being painted all black. And I think that is being interpreted differently by the shader. It's really strange. For some reason, this is coming in at a very strange set of values. I think I need to be a 1, 0 rather than 0, 1. Nope. Okay, so there's something dumb going on that I'm not really figuring out here. My brain shut off, as I mentioned, and I wasn't joking. The range value is between 0 and 1. At 1, we draw more of the default objects. And therefore, at 1, we draw none of the LOD objects. So what I'm trying to do is add 0.5. Maybe. Nope. What? Ha. Wait. Range value plus 0.5. Oh, I'm just a fucking idiot. I'm just a fucking idiot. That's all the problem is. All right. So in theory, they shouldn't start popping in until we get further away. They should be popping in now, though. Yeah, there we go. And you can see how they're large enough that they don't glitter, We have a lot of problem with glitter otherwise. But what we actually need to do here is go between 2 and 0, because we're not going to get all the way down to not going to get all the way down to 0. The range is always going to be between 0.5 and 1.5. So we can use that and just do a little bit of math magic. The only problem with this is that the way I've got it set up, half of these particles will vanish. I guess that's fine for anything over 1,000. But you can see what happened, right? Hold on, I think someone's slamming my front door here. Wasn't that exciting? You got to hear me meet my mailman. Okay, so El Boeche says that it is way too harsh. So the reason that it's way too harsh, El Boeche, is because we're working with very, very low numbers. What we should be doing is using a substantially larger number of fill objects. So right now we're using 1,000. Let's go ahead and use 10,000. Which is the default. So when we have 10,000 objects, it looks like this up close, and as we back up, that doesn't look like 10,000 to me. I think I got an error here, hold on. So for some reason this barfed. What happened here? Len equals position.length minus A, or 1,000. And then B. That should have worked. I mean, we're not talking about anything complicated here. This is super basic. We'll go ahead and just do a quick little debug here. Debug.log A equals, and then A. We'll go ahead and see when it barfs. Oh, I'm just an idiot. Ah, there we are. That's 10,000. So now what happens is, as we back up, we'll start to see those fade away, and then we'll start to see the large objects come in. See? And that's a very, very subtle effect in comparison. Do you see what I'm doing? So let's go ahead and zoom in and get back towards it, and you'll get to see the LOD objects transition over into actual objects. And it should be something that is very gentle. Did you even see it? Hopefully, when you were looking for it. But you shouldn't have really noticed it. It should have been quite nice. And the reason it was really bad before is because I was using extraordinarily low numbers. So, you know. But now that I've done that, I have to admit that using extraordinarily low numbers is something where we may not want to have an LOD group, or our LOD objects may want to have. Okay, so we're going to go ahead and say pos.length divided by 10. That way, if we do have a low number of objects, like 1,000, we're not going to have a full set of LOD objects. We're going to have... All right, so now we've got a lower number of objects. And I don't know whether... It's probably still going to be pretty noticeable because it's so sparse. But it shouldn't be as ugly. Yeah, it's still noticeable, but it's not as ugly. The whole point is that as you get further away, if you keep the small objects, even if you draw the same number of small objects, they turn into sub-pixel artifacting, and they basically glitter. Whenever you move your camera, they flicker, and that's really, really distracting. So by switching them out for larger objects, we end up making them feel a lot more substantial. The other option is I could use some sub-pixel movement correction and stuff like that, but there currently isn't one set up for the new Unity stack, post-processing stack, and I don't really feel like building one myself, so we'll just go with this instead. So this is good in that it can handle any number of objects. It automatically detects whether it's on camera correctly. It automatically does an LOD that actually works based on the physical size of the objects in question. This is better than what we were doing before. Now all we really have to do is have draw instanced descend from draw instanced base instead. I'm getting really hungry though. War Thunder has the glittering effect pretty badly. Yeah, anybody that doesn't go out of their way to avoid getting that glittering effect will have that glittering effect. Most AAA games use a smoothing method, a temporal smoothing method that keeps those effects from glittering. But that, as I said, doesn't exist in Unity at the moment. This actually requires a little bit more work because it does the physics as well. Let's stop here. I'm hungry, and I got to start cooking now if I want to eat next hour. So I guess we'll do that. I hope you enjoyed my revamping of some visuals. Reprogramming something that you watched me program before. And I hope you liked hearing me meet my mailman. Have a good one, and I'll just pay attention to chat for a little while longer, you know, in case someone asks any questions, but I don't expect any. I'll see you on Sunday if you care to stop by.